Hello everyone, I wanted to give you a little update on our Rust journey. So we finished the first project and I want to give you a bit of a recap of lessons learned, challenges that we encountered, best practices, and little tips and tricks that I learned with this language. So without further ado, let's jump right into it. I will say the first thing you're going to want to enable if you're just learning Rust, you want to get more familiar with what is idiomatic Rust. You got to be using Clippy, okay? Clippy is outstanding. I enabled Clippy Pedantic for this project and it was very helpful. I also was using Clippy if I was encountering any errors at all at compile time. I'm asking Clippy. It gives you such great feedback, not only of a very clear description of the error and where the error is occurring, but also gives you suggestions on how to fix it. So instead of first just jumping to AI and trying to get AI to fix things for you, definitely check what Clippy says because it does really make a big difference when you are familiar with the errors that you're getting in your code and when you know how to solve those things. So it is a bit of that like familiarity is what's going to allow you to move faster when you're learning a new language. So that was step one, it was enabling Clippy Pedantic. What I've found with Rust that is crazy is like if I get stuck on something and I'll ask AI, and I'm using Codex 5.3 Codex. I don't listen. I'm not keeping up with the latest and greatest. What is the best AI agent in the last 2 hours? Okay, I don't care. Give me something that works well enough, whatever. But what I find with Rust specifically is I'll be like, hey, why isn't this working? Can you help me? And it'll just like rewrite everything. And I'm like, brother, you've changed the logic. This isn't even the same function. I'll just look at what Clippy said and it's so good at suggestions. Hold on, look at this. Here it's just going over my imports, which is whatever. Here it's saying like, here's an error and also here's how you fix it. And so I found there's so many times where I'm like, I don't know what this error means. And then as soon as I ask Clippy, I'm like, it will actually just tell me what the problem is. Okay, here it's saying, hey, by the way, you're returning a type instead of where I thought you'd be returning nothing. And then here, yeah, it's like, hey, use a semicolon here, you goof. I'll give you a quick little demo on what we're doing here. So pretty much this is a weather app. So it gives you give it a city and a country, and then you give it a temperature unit, which is either going to be Fahrenheit or Celsius. I'll say Fahrenheit for now. And it's actually going to query a weather API and give you the current weather at that location. So in this case, it's a 53 degrees Fahrenheit in London. Building this project meant that I had to work with JSON because I was going to do an API request. So I had to figure out how to do GET requests. I had to figure out how to deserialize JSON into data structures with Serde. I also had to work around, just all these new patterns with this language. The enumerations in Rust are really powerful, and I'm really excited to learn more about how to use these and like their full potential because they are very different than enumerations in Go. Let's first jump into some of the JSON stuff. So Reqwest is the package that you end up using in Rust to do GET requests. And in this case, you end up doing a pattern matching like pretty much all the time in Rust. And for this one, of course, we are either handling the error, meaning we're cascading it up the chain, the caller chain, or we are returning the response. That is for actually requesting the coordinates because the pattern for this thing is that we had to get their coordinates first, and then we were able to query the weather API with the coordinates. So there are multiple stages to this request. We also, of course, had to figure out different data structures that we wanted to use here. But basically on marshalling the JSON was pretty straightforward. We ended up just using Serde for most things. The most complicated thing though was handling temperature. So there was a reused temperature field in the struct. So, well, not reused technically. One of them I think was a temperature, I want to say like temperature unit, and then it would say temperature is Celsius. And then there was a different field for it in the response as well. That was temperature, and it was the actual numeric value of the temperature. So we had to figure out how to deserialize that from JSON, and I ended up using generics for this temp field. And this temp field, you'll see that whenever we're using it, we end up deserializing the Serde into this weather response that allows us to get the unit and the numeric value for the temperature in one place, despite them having the same JSON tag. And then another thing we ended up having to do for this weather response, once we unmarshal that, this was all synchronous, by the way. Our next project, I think, will probably end up having some async components to it, but I'll get into that in another video. You can see here, we do weather response, and then we do this to temperature, which is where I convert it to an actual enumeration. This is for the unit of measure. This is where we're basically using the unit name and the numeric value to map it to our primary enumeration that is either going to be Celsius and Fahrenheit alongside the numeric value. These are new type variants, so it means that they have an actual value associated with them. The unit type ones are when it would just be Celsius or just Fahrenheit. These are all what I've been learning, okay? And then another thing that we ended up having to do is, because we need the user input to figure out what city and country they want the weather for, we actually are working with strings for that user input. So we have to get standard in, and that means that we're getting a string back as a response from the user. I was initially doing string comparison, which was a very brittle test. We had to work on that and actually make it so that the temperature unit, we could convert the string value to an enumeration and then compare the enumerations. See if the result that we got back from the API has the same temperature unit as what the user wants, and if not, we have to convert it. So that's pretty much what the logic is doing here, is that we've implemented the FromStr trait for temperature unit, and then we do have to do a trim as well. Some languages, when you get input from the user, it will include like the carriage returns and stuff like that. Rust is one of those languages, so you do end up having to do unit.trim. But yeah, in this case, I just basically do a conversion with this from string and then map that to one of the enumeration variants, and then that's it. And then otherwise we are handling the errors appropriately. Another big thing that I came across for this project is that the whole notion of having generic error types, I didn't want everything to be like the box din. That is the most generic error type that you can give in Rust. And from what the chat was saying, it's generally not a great practice to use that. Like, you want to limit your usage on that, which is part of why most of the time for people's applications, they'll actually use anyhow errors that allow you to bypass this whole crazy custom error code that you're about to see, okay? You're gonna need to be able to return errors up the call stack. And when you do that, you're gonna probably want to have a error type that is specific to the error that you received. But in order to do that in Rust, you kind of end up having to wrap it in a more generic error type, meaning create an enumeration where each of the errors that you want to accept in that application are a variant of this enumeration. Because otherwise you're going to be stuck with, for example, our request calls request coordinates, and it also calls the weather API for the weather. So if we get a coordinate error and we want to return that to handle in main, and we return that up to request, and then request returns that error type, it's going to expect that every error getting returned from the more generic request call is going to be a coordinate error, but that's not the case. So we had to make it an enumeration so that it could accept a wider range of different error types. This is where anyhow errors can come in, is that you don't have to do this whole custom error thing. Typically people will use anyhow errors where they don't necessarily need as much control over the error type that's being returned. They just want to be able to accept whatever errors you want to return. You will typically see this error being used for libraries, which I believe gives you a little bit more control. But we'll get into that in a future video where I end up using this error. But again, this is still a very common pattern that you end up having to do in Rust, is a custom error type, and it gives you full control over all of the errors required or handled in your project. Another thing that I learned while building this project is definitely that you don't need to put any explicit returns unless you're doing an early return. There were some other things too as well, like for formatting, you can just have it kind of the way that I've denoted here, where it can just be directly in there. This is like one way that Clippy, again, gives you great feedback on just, it was getting rid of early returns and needless borrows, general cleanup for all of that kind of stuff. So definitely listen to Clippy, run your linter. I think the most important thing that I learned from this project is that it gave me hands-on practice with Rust And no matter how much you read, no matter how much you read other people's code, you do have to get your hands dirty. So make sure that you build something. And again, it can just be something small in scope. I find with programming specifically, momentum is such an important part of feeling confident to build things from scratch. Building greenfield projects, building from scratch means that it can just feel so overwhelming at times. So give yourself things that are small in scope, that just get the ball rolling. It doesn't have to be anything innovative. It can just be something that already exists and you are allowed to spend time breaking it down and rebuilding it for yourself so that you get time practicing what it means to build code in that language and you get an understanding of how that software actually works. I would highly recommend just get your hands dirty, build something, and I hope that this can serve as some inspiration of how simple the project can really be, yet still bring a lot of value to yourself in your learning journey. If there was anything that you'd liked in this video, if the format resonated with you, or if there were things that you wish I had spoken more about, if you want me to go more into detail on how the actual code, works together, let me know in the comments. I'm trying to figure out kind of how to explain this in a way that is compelling or interesting to others and summarize what I've learned so that hopefully it can help all of you that are potentially learning Rust, spark some conversation about what is or isn't a best practice in this language. So if you want to follow along with the Rust journey, make sure to subscribe because I will be keeping you all updated on all of the projects that we're building in Rust and how the learning journey is going. And yeah, don't forget to give this a like if you want to support my videos, my channel. I'm also live streaming this whole process on Mondays, Wednesdays, and Thursdays. So if you want to tune in for that and chime in on the live stream, I would love to see you there. But otherwise, I will see you in a future video.